Hello and welcome to another introductory statistics video. Today we'll be talking about confidence intervals for one mean, also known as the one mean t interval. For this example, I will be using a random sample of 1,000 video games from the years 1988 to 2016. You might be asking yourself, why do we need confidence intervals? What do they do? So let's say I wanted to use this sample to predict the population mean critic score for all video games. Well, I could get the summary stats for critic score, and then I could use this sample mean of 70.257 as my one best guess. But we know with continuous distributions, the probability of landing exactly on a single value is next to zero. So if I could guess population parameters within one number, I wouldn't be here teaching. I would be off living comfortably on my casino winnings. So what a confidence interval does is it starts with that point estimate, in this case our sample mean, uses mathematical formula to calculate a margin of error in order to find an upper bound, and it uses that same margin of error to find a lower bound. Forgive me for the glare on the document camera. And it's important to note that this margin of error makes up half the width of the entire confidence interval. So every confidence interval is going to contain two margin of errors. So what this does is instead of a single guess as to what the population mean critic score is, I now have a range of plausible values. But before I can compute this confidence interval in StatCrunch, there are two assumptions I need to check. I need a random sample, and I need either a normal population or a large enough sample size. Now, as previously stated, this is a random sample of 1,000 video games, so that first assumption is going to be met. And we don't necessarily know that critic score is normally distributed, but we do have 1,000 observations in this data set. That's more than enough to meet that assumption. So with those assumptions met, we can construct this one mean t interval. Since it's a t interval, once I go to stat, I'm going to select t stats. We're only working with one sample. And we're working with a spreadsheet of data, so we would select with data. Oh, one more note before I proceed, actually, is that the t distribution, which is the underlying distribution for what's going on here, is slightly resistant to violations of the normality assumption, but it really does not like outliers. And if we create a box plot of critic score, we can see that there are a few outliers in this data set. We're just going to proceed for now, but in real world, it would be good practice to run this analysis with the outliers in the data and then to run it again without them to see what happens. But we're just going to go ahead right now. I'm going to click Stat, T-Stats, one sample with data. I select my variable of interest up top, critic score. Under perform, I want to switch it from a hypothesis test to a confidence interval. And then here you can adjust the confidence level. The confidence level is part of the mathematical computation for finding that margin of error. The higher your confidence level is, the wider your interval is going to be, but a really small confidence level can lead to a really precise interval. Think about it. I could be 100% confident that this population mean critic score is between 0 and 100. That doesn't really help us that much. Whereas I could be 1% confident that it is exactly 70. Again, not very helpful. So typically we stick to 90, 95, and 99% confidence intervals. For now, I'm just going to go ahead and run with the 95%. So I'll hit compute. This output will give you the sample mean, the standard error used to find that margin of error, the degrees of freedom, which at the intro level, you do not need to know what degrees of freedom means. All you need to know is that we have 999 of them. And it gives you the lower and upper limits for your confidence interval, the things that we're looking for. All right, so now I have these numbers. What do they mean? How do I interpret them? Well, in my class, we actually offer a fill-in-the-blank interpretation as to how you would interpret these confidence intervals. You need to state your confidence level, the parameter that you're estimating, the context from the problem or real-world scenario, and then your lower and upper bound. So for this example, let me just write it out on the document camera over here. Again, forgive me for the glare. It's going to be in the middle somewhere. I am 95% confident you're going to have to take my word that's a 95 right there, that the true population mean, since we're dealing with a quantitative variable, of critic score, that's just the context, is between, I'm going to try and dodge that glare, our lower and upper bounds, which are 69.41 and 71.11. So instead of just using that 70.257 as a single best guess, we now have a range of possible values that we think the population mean critic score could fall in. All right, so now you know how to construct and interpret confidence intervals. I'll see you in the next video.